Acid and base, part 2a. Define strong acid and weak acid. This table shows difference between strong acid and weak acid. Alpha, degree of dissociation of strong acid is 1, where it dissociates completely into ion in water. While for weak acid, alpha, degree of dissociation is less than 1, where it dissociates very slightly into ion in water. Dissociation constant Ka. Ka for strong acid is extremely large, while for weak acid, Ka is very small. Concentration of acid for strong acid can be obtained directly from original concentration of acid. For weak acid, concentration acid cannot be obtained from original acid. Example, we have HCl, HBr, Hi, and other oxo acid like nitric acid, sulfuric acid, and perchloric acid. Weak acid, this is an example of weak acid. Example, we have acetic acid and benzoic acid. Reaction equation. For strong acid, general equation is Ha react with water, dissociate completely, produce hydronium ion and anion. Example, we have nitric acid, dissociate in water, produce hydronium ion and nitrate ion. Concentration, hydronium ion, we can get directly from concentration original acid, nitric acid, 0.01. For weak acid, example, we have acetic acid, dissociate partially, produce acetate ion and hydronium ion. Concentration, hydronium ion cannot get directly from concentration acetic acid. Strong acid and weak acid. Example, we have HCl as a strong acid. HCl dissociate in water completely, produce hydronium ion and chloride ion. Dissociation is 100% complete. For weak acid, example, we have HF, dissociate in water partially, produce hydronium ion and fluoride ion. Dissociation is partially. Notice here, only small fraction of the dissolved molecule ionize into hydronium ion and fluoride ions. The solution contains many intact HF molecules. Why? For strong acid HCl, the solution contains no intact of HCl. Define strong base and weak base. This table shows difference between strong base and weak base. Alpha, degree of dissociation for strong base is 1, where it dissociates 100% into ion in water. For weak base, alpha less than 1, where it dissociates very slightly into ion in water. Dissociation constant Kb for strong base is extremely large. Why? For weak base, Kb is very small. Concentration of base. For strong base, concentration hydroxide ion can be obtained from original base. Why? For weak base, concentration hydroxide ion cannot be obtained from the original concentration of base. These are some examples of strong base: lithium hydroxide, sodium hydroxide, calcium hydroxide, and barium hydroxide. For weak base, molecule with nitrogen atom that has a lone pair electron is best example for weak base. Example, we have ammonia and methylamine. Reaction equation. Consider we have NaOH sodium hydroxide as a strong base. Concentration sodium hydroxide 0.01. So concentration of hydroxide ion is 0.01. For barium hydroxide, concentration barium hydroxide is 0.01. So concentration hydroxide ion double from original concentration barium hydroxide. Example, we have weak base. Ammonia dissociate in water, produce ammonium ion and hydroxide ion. Concentration OH minus hydroxide ion for weak base cannot be obtained directly from original base. Strong base, weak base. Consider we have sodium hydroxide. Sodium hydroxide dissociate completely, produce sodium ion and hydroxide ion. While ammonia, weak base, dissociate partially in water, produce ammonium ion and hydroxide ion. Dissociation is partially. pH or POH, strong acid and strong base. Consider we have strong acid hydrochloric acid 0.02 molar. To determine pH, first we write equation. HCl dissociate in water, produce hydronium ion and chloride ion. Concentration HCl is 0.02 molar. So concentration hydronium ion is 0.02 molar since HCl is strong acid. So substitute in equation pH equal to negative log concentration hydronium ion, pH equal to 1.7. Next, strong base. Consider we have barium hydroxide concentration 0.00035 molar. First, we write equation. Notice here concentration hydroxide ion 2 times from concentration of barium hydroxide. OH minus hydroxide ion equal to 0.0007 molar. Substitute in equation pH equal to negative log concentration hydronium ion. Concentration hydronium ion we can get from formula Kw over concentration hydroxide ion. Kw 1 times 10 power of minus 14 over 0.0007 molar concentration hydroxide ion. So concentration hydronium ion 1 times 10 1.43 times 10 power of minus 11. Substitute in our equation, then value of pH equal to 10.85. Alternative method to determine pH. We know pH plus POH equal to 14. POH equal to negative log concentration hydroxide ion. Substitute concentration hydroxide ion 0.0007. So POH equal to 3.15. To determine pH, pH equal to 14 minus 3.15. pH equal to 10.85.